All right, factoring. If your multiplication skills are a little bit weak, this will be slightly challenging because the whole point is we are doing the opposite of expanding. So here we have something in expanded form after distributive property, and we're trying to take it back. So we want to know what number did we multiply these two terms by, or the previous two terms in brackets, to get 14x and 7. And the way that we do that is we think about the factors of 14 and the factors of 7, and we're trying to find the greatest common factor, so the highest number that they have in common. I'm going to list the factors of 14. So I know that 1 goes into 14 because 1 times 14 is 14. I know that 2 goes into 14 because 2 times 7 is 14. 3 doesn't, 4 doesn't, 5 doesn't, 6 doesn't, 7 does, and it's right here, so that's it, I'm done. The factors of 7, I know that 1 goes into 7 because 1 times 7 is 7, and that's it. There's nothing else because 7 is a prime number, so those are my only factors. Now I'm going to look at which ones they have in common. They have the 1 in common, and they have the 7 in common. The greatest number, the highest one, is 7. So that is my GCF, my greatest common factor. So that's the number that I'm going to have in front of the brackets. I'm going to say 7. And then inside the brackets, to figure out what I put there, I'm going to divide the remaining terms by 7, because that's what I took out. So I'm going to divide this by 7, and I'm going to divide this by 7, and that's what's going to go inside the brackets. So 14x divided by 7 is 2x, and 7 divided by 7 is 1. And that's it. If I wanted to check, I could do the distributive property. 7 times 2x is 14x, and 7 times negative 1 is negative 7. So that means I did it right. Let's take a look at example B. So this is also common factoring. So I'm going to look for common factors. I'm going to look at the coefficients and list their factors. So the factors of 20. I know that 1 is a factor of every number. So 1 times 20 is 20. So I know that that's a factor. I know that 2 goes into 20 because 2 times 10 is 20. 3 doesn't, 4 does. 4 times 5 is 20, and that's it. My factors of 5 is also prime. Remember, prime means that it only has 1 and itself as its factors. So 1 and 5 are the factors. So here they have 1 and 5 in common, and the greatest is 5. For the variables, the greatest common factor is the highest exponent. So here they both have an x, but the highest one is, sorry, the lowest one, not the highest, the lowest. The lowest is the one that they have in common. You can think of it like this. X to the power of 3 means x times itself 3 times, and x to the power of 2 means x times itself. So what they have in common are 2 of these x's that they have in common. So that means my GCF for the whole term is 5x squared. So it's the lowest exponent. That's what I'm going to bring to the front. 5x squared. And then in brackets, I'm going to divide out 5x squared. So 20 divided by 5 is 4. X to the power of 3 divided by x to the power of 2. Remember we subtract the exponent, so that's just x. plus x to the 5x squared over 5x squared is just 1. And that's it. The last one looks a bit challenging because it's long, but we're following the same idea. I'm going to start off by listing the factors of my 3 coefficients. So 14, I have at the top, I'm just going to copy the factors, 1, 2, 7, and 14. Factors of 21, 1, because 1 times 21 is 21. 2 doesn't go into it, 3 does, because 3 times 7 is 21. And 4, 5, and 6 don't, so that's it. 63. 1 goes into it because 1 times 63 is 63. 2 does not. 3 does. If you're ever not sure, you could always use a calculator and try using the calculator to divide. So if I want to know, okay, well, does 3 go into 63? I can work backwards. So 63 divided by 3 is 21. So I can put 3 and 21 as the factors. And then does 4 go in it? This gives me a decimal. That means that 4 does not go in it because it gives me a decimal. I know that 5 doesn't because it ends in a 3, not a 5 or a 0. 6, well, I would know that 6 doesn't because I know that 6 goes into 60, but this is 63, so there is no other 6's in there. Or you can just test it using the calculator and you see that you don't get a whole number. 7. So it goes in 9 times, so 7, 9, 8 does not, and 9 is already there, and that's it. Because I've come to the number that I already have, that means that there are no other factors. There aren't going to be any other numbers in between. Okay, so the numbers that they have in common are, like above, 7. That's what I'm going to divide out. So my greatest common factor is 7. And then I look at the variables that they have in common. So they all have an m in common. The lowest one is m to the power of 2. They all have an n in common, and the lowest one is n to the power of 3. So I know this might be tricky for some of you because we're looking for the lowest exponent, but the highest factor. So just keep that in mind. So now I'm going to divide it out. The thing is, our first term has a negative sign in front of it, and math convention is that in our brackets, we don't want to start our bracket off with a negative number. So what we're actually going to do when the first number is negative, our GCF is actually negative 7, m squared n to the power of 3. So that's what I'm going to divide out. Every term I'm going to divide out negative 7m squared n to the power of 3. Okay, and that's what I'm going to bring over to the front, negative 7m squared n to the power of 3. So what I have left, negative 14 divided by negative 7 is 2. See how this number is positive now? Otherwise it would have been negative, and that's not proper math form. M to the power of 2 divided by m to the power of 2, they cancel out. N to the power of 10 divided by n to the power of 3, we subtract the exponent, so that would be n to the power of 7, plus 21 divided by negative 7 is actually going to be negative 3. M to the power of 7 divided by m to the power of 2, I'm going to subtract the exponent. Gives me m to the power of 5. These cancel out. And the last term, 63 divided by negative 63 divided by negative 7 is going to give me positive. So then I look at the exponent. So m to the power of 3, m to the power of 2. and n to the power of 5 divided by n to the power of 3, I'm going to subtract, and I get n to the power of 2. And that's the final answer. And the last common factoring example, I have 2x to the power of 4y minus 3x to the power of 2 minus 3. So I'm going to look for the GCF first. My factors of 2 are 1 and 2. There's nothing else that can multiply to make it. Factors of 3 are 1 and 3. Notice how none of them have common factors, so that means there's nothing I can factor in terms of the coefficient. But I'm going to look at the variables. They all have x's beside them. And the lowest one is x to the power of 1 over here. So that means my greatest common factor is x to the power of 1. This one has a y beside it, but none of the others do, so they don't have a y in common, which means I'm going to factor out just the x. That means I'm going to divide it out of each term. So it's the opposite of multiplying. I'm dividing it out. And I'm left with 2x. When I subtract the exponents, I get 3y minus, subtract the exponents, 3x. And subtract the exponents and I get 0, so just minus 3. And that's the final answer.